exam preparation. So in the previous video I have discussed about clock problems. In this video I am going to discuss with you about calendar problems. So before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. So calendar problems, one of the question will be compulsory from this topic. So first you should know basic information regarding calendar. So how many days in a year, how you can identify odd days, and how you can define the leap year, and you can try to solve with the some of the tricks that I am going to discuss with you. So if you take calendar, you are going to come across 12 months. So 12, in each month you are going to have around 30 to 31 days, and for leap year if you consider, that is February 29th, one day is going to be added. That's why it is called the leap year. So every 4 years we are going to get. So first we should know how exactly the 365 days in a year. So why? Because when if you take the earth revolves around sun in a solar system. So if the earth want to rotate the sun completely, so for one rotation it will take 365 days. So that's why in 1 year we come across 365 days, but it is not exactly 365 days, it is going to take 365.2422. So for every year if you take the 0.24 is going to be added. If you take this 0.24 for 4 years, if you add all the 4 years days, then we are going to get 4 times into 365.24, that is 1460.9688. This 0.9688 is nearly equal to 1 day, whole day. So this is what the extra day we are going to come across. That's why in month of February we are going to come across 29th day. Usually so normal year, if we take ordinary year, that is 28 days. If we take leap year, it includes 1 day extra. So that's why 29 days. We call that as leap year. So that's why the calendar adds every 4 years. That is the leap year we call. If you take the leap year, it is always even in number. That means 4 years after we are going to get 2008, 2012, 16, like that. So it is always divisible by 4. So next, how we define odd days? If you take 1 year, so it consists of 52 complete weeks. So number of days more than that we call as odd days. So if you take 365 days, then in 1 year 52 weeks, 52 into 7, 354 we will come 364 we will come across. 1 day is going to be extra. So that is how we can define odd day. Leap year, as I discussed, leap year consists of 366 days. 1 day is going to be added. So it is always divisible by 4, and if it is this leap year is divisible by 100, it is also divisible by 400. So these two conditions you should remember for leap year. As we know, ordinary year 365 days. How to identify odd days? So there are some tricks you can apply to identify odd days. Before finding odd days, first January of the year, if you take after that we have considered it on Monday. So we must consider 0th day as Sunday. So after Christ, if you take the 1st January of the year is Monday. Before that it must be 0th day must be Sunday. So first day, if Monday, then the sixth day is going to be Saturday. So then we can assign here days of the whole week related to odd days. So number of odd days, Sunday to Saturday you can write. So as we know, 0th day is going to be Sunday, 1 Monday, Tuesday 2, Wednesday 3, Thursday 4, Friday 5 and Saturday 6. So like that we can identify odd days. So month of the year, how you can identify the odd days? So January if we take, so the total number of days 31 in January month. So there will be 3 odd days. February if you take 28 or 29. So for 28 the odd days are going to be 0, and for 29 if you take 1 odd day. Just you have to use this tabular column to identify odd days in month. So Sunday 0, up to Saturday 6. Then March if you take there are 3 odd days. So the month which have 31, they are going to we come across 3 odd days. You can also divide it by 7. So 31 divided by 7, you are going to get 3 odd days. So 30 if you take 2 odd days. So the months which we are going to have 31, we will come across 3 odd days, and month which we will have 32 odd days, and the February especially if you take 0 or 1, 28 days or 29 days if you consider. So follow these important tricks to solve any of the given problem. So next let us take the example 365 days. How many odd days we will come across? 52 complete weeks, and 1 day is going to be extra, so that is what we call odd day. If we take 366 days leap year, 52 complete weeks plus 2 days extra, so 2 odd days. 100 years if you take, so first let us consider ordinary year 76, leap year 24, because every 4 years we are going to get leap year. So in ordinary year we will come across 1 odd day. If you take leap year, 2 odd days. So multiply with that, 76 into 1, 24 into 2, 124 days. Again you can divide it by 7, because in 1 week 7 days. So 17 into 7 plus 5. So if you do, this will be 119 plus 5, that is 17 weeks plus 5 days extra in 100 year. So 5 odd days will be there in 100 year. 200 if you take, 100 into 2, 100 5 odd days, 5 into 2 10 days. So in 1 week 7 days. So 1 week plus 3 days. So 3 odd days in 200 years. 300 year, 100 into 3 15 days. 2 week plus 1 day. 400 year. So 100 consists of 5 odd days. 5 into 4 20. So 1 day is extra in leap year, so 21. So 0 odd days in 400 year. So like that you can calculate the number of odd days in a given year. So tricks and shortcuts for quick calculation. Month. So let us take the month, 3 months, January to March, 90 days. And year of odd days 6. So leap year if you take ordinary year 6 odd days. For leap year total number is going to be 91 for 3 months and 0 odd days. So April to June 91. So odd days 0, and for leap year also odd days 0. So July to September same 92 for leap year, and ordinary year 1 odd day. So October to December same 92 days for ordinary as well as leap year, and 1 odd day. Only January to March if you take, for ordinary year 90 and 6 odd days, but leap year 91 days, 0 odd days. So what are the steps to solve or find the day of a given date? So first step is find the odd days until the previous year, century of the year in the given date. Let us take 1900 year. So here it consists of 1600 year, that is how we can consider leap year, plus 300 year. So for leap year 0 odd days, 300, 1 odd day. So 1 odd day for 1900 years. Step 2, find the odd days from the first year after that century until previous year of the given year. So let us take 1901 to 1990. Step 3, find number of odd days in month. So step 4, find the number of odd days of the day. 5, add results of all the 4 steps and you will get the number of odd days and multiply it. Take the mod of 7. So step, once you take the mod of 7, how many days you will get, match with this table. So 0 is for Sunday, Monday, first day, so up to Saturday, 6th day. So if the reference day is given, then follow these 2 steps. If they have not given this reference day, you should follow these steps 6, and if they have given, so first step 1, find the net number of odd days for the period between the reference day and the given date. So second step, the day of the week on the particular date is equal to number of odd days ahead or behind the reference day, depending on whether the reference day falls before or after the given date. So you should note down before that whether the interval has leap year. If leap year, whether the February of the leap year falls in the interval or not. Condition for calendar of 2 different years to be same. So first one, both the years must be of the same type, that is either both must be non-leap year or both must be leap year. The net number of odd days for the period between their 2 years should be 0. So these 2 steps you should follow for 2 different years to be same. So let us take example here to understand. What was the day of the week on 17th October 1991? So here you should find out the day. So follow all the step 6. So step 1, odd days in the year 1990. As I said, 1600 plus 300, if you do 0 plus 1 odd day in 300 year. So 1 odd day if you take 1900. Odd days from 1901 to 1990. So 90 by 4, 22 leap years. 90 minus 68 ordinary years. So leap year 2 odd days, ordinary year 1 odd day. So multiply, you will get 122 odd days, or take mod of 7, you will get 0 odd days. Step 3, number of odd days in months. January to September. Here they have given up to 17th October. So before that, January to September. So in each month, how many odd days you will come across? Add up to September, January to September. So 21 mod of 7, if you take 0 odd days. So step 4, odd days from the given date. 17th October if you take, 1st to 17th October, 17 days, mod of 7, 3 odd days. So add all these steps. So in step 1 we got 1 odd day. Step 2, 0 odd days. Step 3, 0 odd days. Step 4, 3 odd days. Add all these, you will get 4 odd days. So 4th day, if we take, that is going to be according to previously as I discussed, 4th odd days related to Thursday, because Sunday is 0, Monday 1, Tuesday 2, Wednesday 3, 4th is Thursday. So 17th October 1991 will be Thursday. Like that you should solve. Today is Wednesday. 76th day from today will be. A day repeat for every 7 days, as we know. So each 7th day is going to be Wednesday. 76. If you want to 7 into 10, so 17th day is going to be Wednesday. 76th, 70 plus 7, that is 77th day is going to be Wednesday. So before that day, 76th day is going to be which day? Tuesday. Okay. So like that you can identify the day. What was the day of the week on 17th October? Already I have solved this. So the last day of the century cannot be. So you must follow the number of odd days in particular year, century, 100, 200, 300, 400. As I discussed earlier, 100, 5 odd days, so that is Friday. 200, 3 odd days, Wednesday. 300 year, 1 odd day, Monday. 400 year, 0 odd days, Sunday. So then this cycle is going to repeat. So we can come across all these 4 days except Tuesday, Thursday or Saturday. That could not be a leap year. Last day of the century could not be Tuesday, Thursday or Saturday. Then here we can come across Monday is going to be leap year, Wednesday, Friday, but Tuesday is not the leap year. That's why answer B. So if want to discuss conditions for calendar of 2 different years to be same, both the year must be same type, either both must be non-leap year or both must be leap year. So the net number of odd days for the period between these 2 years should be 0. So let us take one example. The calendar for the year 2015 will be same for the year. They have given 4 options here. So 2015, you must first take the years and extract the number of odd days. 2015, so this is a non leap year. So 1 odd day, 16, 2 odd days because it is a leap year. So ordinary year, if you take each ordinary year consists of 1 odd day. So follow this cycle, and once you get the sum of all these odd days up to 2000, whenever we are going to come across the 0 odd days, that is going to be the calendar for the year 2015, same for the year for the given options. So if we add up to 2015, if we consider these given options, 2025, 14 odd days we come across. That means 14 divided by 7, if we take mod of 7, this is going to be 0. So that means the 2016 is going to be similar or the same as the calendar for 2015. So some of the previous CSIR NET questions if we want to solve. So the first question, if a 4-digit year, let us take 1927, is not chosen randomly, what is the probability that it is not a leap year? Anyhow, leap year is going to be repeated for 4 years. So many of the years if you take, if we select randomly any of the year, maximum it is going to be non-leap year. So it should be divisible by 4, and it is divisible by 100, it must be divisible by 400. So that means here the option D is going to be correct here. So the non-leap year. Maximum number of Sunday and Saturdays in a leap year. So If in a leap year 52 weeks 2 odd days, 52 Saturdays plus 52 Sunday, if you add 104 days, 104 leap year 2 odd days, so 106 days. November 9, 1994 was Wednesday, then which of the following is correct? So if we read all the 4 options, common is 1965 and 1990 November. So let us take the first November 9, 1965 up to in the question they have given November 9, 1994. So if we do the calculation, total 29 complete years. If we divide it by 4, 7 leap years. So 29 minus 7, 22 non-leap years. So then we can calculate odd days by leap year and non-leap year. One odd day we will come across. So the given reference day is what? Wednesday. So if we subtract one day, we will get the November 9, 1965 is a Tuesday. So second, they have given condition November 9, 1917. So here also if we calculate the leap year and non-leap years, so 24 minus 6, 18 non-leap years, 6 leap years. So 2 odd days for the given date. Reference day is Wednesday. Before that 2 days is going to be Monday. So here Monday and Tuesday are not in the options. So option D is correct. November 9, 1965 is not Wednesday, not for 1970 also not Wednesday. So a certain day which is X days before 17th August is such that 50 days prior to that day, if it was 4x days. Since March 30th of the same year, what is the value of x here? So we have to consider here from 30th March to August. So August 17th. So 30 after that 31st March, one odd day. April in the April month 30 days. May 31st day 31 days. June 30 days. July 31 days, and August they have given 17th August. So 17 days. If you add 140 days. So what they have given, x plus 50 days prior to that, it was 4x. So 4x plus 50 plus x is equal to 140. So x is 18. So like that you can solve the problems related to calendar. I hope these tricks and method of solving any of the problems on calendar